long day after. Today I will discuss again reducibility and irreducibility of ring theory. Today I will actually discuss some question of ring theory which had come different type of competitive exam. At first I will say some rules of reducibility and irreducibility. This is the simple and basic rules. If fx belongs to fx such that degree of fx equal to 1, where f is a field, then fx is irreducible over here. This is true only when f is a field. 1 degree polynomial always be irreducible when f is a field. If consider fx equal to 2x plus 2 is a polynomial of degree 1, but fx is not irreducible over z. If fx belongs to field, then we can tell fx is irreducible over the field. But since z is not field, so this polynomial is not irreducible over the field. Okay. If fx belongs to z is such that degree of fx greater than 1, then fx is irreducible over c, and fx belongs to zx is such that degree of fx is strictly greater than 2, then fx is reducible over R. Consider, as for example, fx equal to x to the power 5 minus 3x to the power 4 plus 2x cube minus 5x plus 8. Notice here degree of fx equal to 5, which is strictly greater than 1. So we can tell fx is reducible polynomial over the field R. Since here degree greater than 2, so this is the reducible polynomial over R, and over C, when degree of fx always strictly greater than 1, then this is always reducible over C. Similarly, if we consider fx equal to x to the power 4 plus 7x square plus 8x plus 11. Here degree of fx is 4, which is greater than 2. So that implies fx is reducible polynomial over R. Okay. One question which had come GATE 2013 exam. The question is, which of the following is a field? Option 1, Cx modulo ideal generated by x square plus 2. Option 2, Zx modulo ideal generated x square plus 2. Option 3, Qx modulo x ideal generated by x square minus 2. And option 4, Rx modulo ideal generated by x square minus 2. All of us know, if R is a PID, then one non-zero proper ideal is maximal ideal if I, who is generated by fx, is a irreducible polynomial over R. Then we can tell the ideal I, which is generated by fx, is a maximal ideal. Then we can tell Rx modulo ideal generated by fx is isomorphic to field. Okay, here this Rx is PID and Fx is irreducible polynomial over R. Okay, OL. For example, if Fx belongs to real line, if Fx belongs to real number and degree of Fx strictly greater than 2, we all of us know, few minutes ago I have seen, when Fx belongs to real number, since degree of Fx greater than 2, so Fx is reducible over R, and since Fx is reducible, so Rx modulo ideal generated by Fx is not a field. Since this is not a field, so this ideal generated by Fx is not maximal ideal. Of Rx. I hope my all viewers have understood. And since Fx is reducible over R, so this ideal Fx is not prime ideal also of Rx. Okay. So since this ideal generated by Fx is not prime ideal, so this is not only field as well as this is not integral domain also. Similarly, let Fx belongs to Cx and degree of Fx greater than 1, then since degree of Fx greater than 1, so Fx is reducible over C, so Cx over ideal generated by Fx, this is not a field. So this ideal generated by Fx, since this is not a field, ideal generated by Fx is not maximal ideal, since Fx is reducible polynomial, and since Fx is reducible polynomial, this is not only maximal ideal, this ideal Fx is not prime ideal of Cx. So this is not only field, this is also not integral domain. Now let's see what is the solution of the question GATE 2013. You will understand after that easily this question. First, Cx modulo ideal generated by x square plus 2. Since here the polynomial is strictly greater than 1, so over C, this ideal generated by x square plus 2 is not a reducible polynomial. This is the reducible polynomial. So ideal generated by x square plus 2 is irreducible polynomial over C. So ideal generated by x square plus 2 is reducible polynomial. So this can Cx modulo ideal generated by x square plus 2, this is not isomorphic to field. Second, Zx modulo ideal generated by x square plus 2. Notice when R is PID, when the ring is PID, then the following rules for maximal and prime ideal, the polynomial, the ideal generated polynomial if irreducible, then we can tell this is be reducible, this is be the isomorphic to field or integral domain. Since Zx is not PID, so we cannot apply these rules. This is not isomorphic to field. When the ring is PID, then we can tell when ideal generated by fx is irreducible, then this is isomorphic to field. Here qx, here cx, qx, rx all are PID. Ideal generated by x square minus 2. This is the irreducible polynomial in qx. So this is isomorphic to field. But notice option 4. For fourth, x square minus 2, we can write this as x plus square root of 2 times x minus square root of 2. This polynomial we can write as a factor. So Rx modulo ideal generated by x square minus 2, we can write by product of two reducible polynomial in Rx. So this is not isomorphic to field. Since this is product of two reducible, we can write x square minus 2 is product of two reducible polynomial, because here the root belongs to in R. Here, since the root does not belongs to in Q, so we cannot write this is as product of two reducible polynomials. So this polynomial is irreducible in Qx, but this polynomial is reducible in Rx. So this is not a field. I hope my all viewers have understood clearly this question. Okay? Oh well. Question which had come CSIR net examination. The question is Rx be a polynomial of one variable R and I be a subset of Rx which is ideal. I be a ideal in Rx, then option 1, I is maximal if I is non-zero prime ideal. Option 2, I is maximal if Rx modulo I isomorphic to R. Option 3, I is maximal if ideal I which is generated by fx, where fx is non-constant irreducible polynomial over R. Option 4, I is maximal ideal if there exists fx belongs to ideal, where degree of fx less than equal to 2, which is non-constant. Which of the following is true option? This is very conceptual question. If you know the theorem which I had discussed few minutes ago, if you know the statement, then you can verify this question very easily. At first recall again, if f is a field, then fx is PID, and in PID a non-zero prime ideal always imply maximal ideal, and every non-zero maximal ideal is generated by always irreducible polynomial, and every irreducible polynomial generates always a maximal ideal. Now see the option. I is a maximal ideal if I is non-zero prime ideal. Since R is a field, that means that imply Rx is PID, and in PID every non-zero prime ideal be a maximal ideal, also every maximal ideal be a non-zero prime ideal. This is if and only if condition. This will be the if and only if condition. So option 1 is the right option. I is maximal if Rx modulo I is isomorphic to R. Notice ideal generated by x square plus 1. Rx modulo ideal generated by x square plus 1, this is isomorphic to C, and C is field. since C is field, the ideal generated by x square plus 1 is a maximal ideal. So, option 2 also be right option. Wrong option, because here this is isomorphic to R. This is not always true. For this ideal, this is isomorphic to C. Option 3, I is maximal if I equal to ideal generated by fx, where fx is non-constant irreducible polynomial over R. Option 3 also right option. If I is generated by fx, if fx is non-constant irreducible polynomial, then always that imply I is maximal. So option 3 is right option. Option 4, I is maximal ideal if there exists fx such that degree of fx less than equal to 2. I have seen in Rx, when degree of fx strictly greater than 2, then that imply I is always reducible polynomial in R. Since here degree of fx less than equal to 2, when degree of fx less than equal to 2, then in Rx, I is always, this type of polynomial always be irreducible polynomial. So this is be the maximal ideal in Rx. So option 4 also right option. That means option 1, option 3 and option 4 be the right option. I hope my all viewers have understood this type of question. This type of question actually very conceptual question. If you know the theory, then you can easily solve this type of question. Okay? Today I will stop here. In my next video, I will discuss this type of question about maximal ideal, prime ideal. This type of question also just as a review. But at first I will hardly recommend you please see my previous video with pay attention. If you don't see my previous video, please see the playlist also. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.